Alright, so let's see how this goes. This is my first attempt at a stream, which is more like a recording of myself trying to do these daily problems. Okay, so this being the first one, I should probably mention that I'm going to try to do this kind of live and not know the problems ahead of time, so it might be a little rough in terms of pauses. Okay. Alright, so let's see what we got here. Length of the longest Fibonacci subsequence. Alright, so we have a sequence that's Fibonacci-like, so not exactly Fibonacci. N is greater than or equal to 3. So the sequence has at least 3 terms. Okay, the sum of the ith plus 1 term is the sum of the previous 2 terms. From that, that's reasonable. Given a strictly increasing array of positive integers, return the length of the longest Fibonacci-like subsequence. If one does not exist, return 0. Okay, the subsequence has to be at least 3 long, so it can't be just like a single number or 2 numbers. Okay, that's reasonable. A subsequence is derived from another sequence by deleting any number. Ooh, okay, so this is not a subarray, this is a subsequence, so subsequences are non-contiguous, or they can be kind of elements that are kind of spaced apart. That being the case, they do have to form a sequence, so they have to be logically kind of in the order that they're seen in this array. So like subsequence might be like 3, 5, 8, 3, 4, 7. Subarrays are subsequences, but not all subsequences are subarrays. Okay, so let's start by creating a simple variable to identify the length of the array and the longest Fibonacci subsequence. Okay, so I feel like this is one of those ones where it's probably dynamic programming. For dynamic programming, you can possibly tell because up to any certain value in your input, you kind of have the optimal, you can have an optimal answer for that value, and it kind of, you can use that to determine the next incremental best value. I'm actually not sure exactly how to define when I think dynamic programming is the choice, but I'm pretty sure it is, that this is using that. So how would I use dynamic programming in this instance? So let's say I have dp as a dynamic programming array, and for any, let's say I look at my array, if I have to start with like at least 2 prior values, so really it should start with like the 3rd value, because that's the first one where it could technically be a Fibonacci sequence. Now this sequence itself is increasing, so I at least know that. I don't have to worry about decreasing values. And I can delete, so delete any number of elements. I'm not going to consider it as deleting, I'm just going to consider it as like skipping over elements. So for instance 3, 4, if this is a valid sequence, then this is going to be 7. So like 3, 4, and the next one would be 7. And then like from there it'd be like 4, 7, the next one would be like 11. 7, 7. So for any two spots, the next spot could be determined by it. So I can look for a 7, but because it's a 3, 5, it could be an 8. Oh boy, maybe dynamic program isn't it here? There's multiple ways to get to a particular index. That could still count. The longest subsequence of this example is 1, 2, 3, 5, 8. Longest here is 1. It'd be 3, 11, 14, or 1, 11, 12, or 7, 11, 18. All right, just to give myself a little incentive, I'm gonna just give myself a timer here. Hopefully solve this in 20 minutes. All right, let's just try something here. For any particular value, I can add that value to all the possible. I can see if that value either links to a previous value that has a chain. If not, then it technically could combine with any. Prior value and start a new possible chain. So for instance, 3, 4, when you see the 5, you know it doesn't link up with the 3 and 4, but it could link up with the 3 and form a new chain that's like 3, 5, or to link up with the 4 and form a new chain that's 4, 5. How to make that? How long is this? So the constraint here is the array is 1,000 long. Okay. The array is 1,000 long. So 3, 4. I feel like it's still dynamic programming in some ways, but let's go and just try it without it. So for every value in, let's say v0 is equal to array at 0. So this is kind of the previous value. v1 is equal to array at 1 for every value in the array starting at the 0, 1, 2, the second spot, or second index, third spot. Let's say if the value is equal to v0 plus v1, And then answer equals plus equals 1. Actually, the return value is the length of the array. Streak is equal to 0. Streak equals 0. Then answer is equal to 3. Else answer is equal to 1, or increment by 1. But here could be any two prior values in the array. Length of the longest subsequence. I wonder. Okay, maybe, yeah, this does not work. I think maybe I'm gonna have some sort of track of the possible sequences of different lengths. So let's say sequence is going to be a default dictionary of lists. Every value that I add should be appended to the sequence. And the sequence here is defined by this as possible sequences by length. Okay. For every value in my array, sequence of 1 is going to append that value. So you can start a Fibonacci sequence with that value. And then for every is that how I want to do it? So if I go using the index that is the length, then if I did sequence at 2, it would be appending anything that is the current value plus anything that is any element within sequence of 1. So any one length list, add on to it the current element to create a 2-length list, 2-length sequence, and add that to my overall dictionary. And then if I looked past that, so if it was like a number that was 8, I want to determine that it was possible to be added to a sequence that's a length 2, like 3 and 5, then I have to look through all the elements within the sequence 2, which is all the possible pairs of things before it. I don't know that that's a lot of pairs. That's a lot of pairs. Is there a way for me to limit the pairs just to tell? I think there is. I think it's think it's using, instead of the length of the sequence, like using the index storing. Yeah, I think it's storing within the dictionary the next element that you can use. Yeah. So yeah, okay. You still should be able to start with any value though. So starting values, I'll make this a set, and then this is sequence has possible sequences ending with this particular one. Okay, I have something in mind. It's hard to describe here, but basically for every val in my array, I'm going to eventually add that val to my starting values. But for every current, let's say sval, which is the starting values, and I'm going to do sequence, let's say, so if there's a starting value, like we're dealing with like 3, and we're at current value is 4, the total is going to be sval plus val, and we're going to say the sequence at this spot in the index is going to append this possible thing. So 3, 4 is going to be 7. So I'm going to say that if I look up 7, it will note that there's a possible sequence that goes up to it, and in particular it needs to know the length up to it. So let's say the length here is going to be 2 and the last value in that sequence, because that will determine what the falling number might be. Okay, so for instance, if s value is 3 and value is 4, then it's going to add onto my sequence at 7. Yeah, that's fine. Add onto my sequence at 7 that there's previously two elements, maybe 3. Previously 2 elements, and the last element was 4 to reach this value of 7. Okay, I think that makes sense. Now, that being the case, if it was to be later on, then when I start off and I see 7, I should look into the sequence dictionary to see if there's already like prior combinations that could combine to 7, and then start like adding on to that. So for every combo in my sequence at this spot, so if I'm 7, I see that there's a 2 sequence that is ending with 4 before this that gets to 7, then I'm going to do length and last is equal to this combo sequence of well, this current value, which is the sum of those two, plus plus the last number dot append. Now is going to be length plus 1, and the last value is going to be this value. Okay. And let's go ahead and add some answer here. Oh, this should be length plus 1. What am I doing here? If length plus 1, yeah, if that current length is greater than the answer is equal to length plus 1. Alright. I think this actually kind of works. Let's see how it goes. All right, let's append. Whoops, I should make this a tuple. Or oh, okay, it works for the first two cases. I mean, I have a feeling it works. Wow, this is a very slow algorithm. Oh boy. All right, let me see if I can consider how I can make this faster. This does not beat very many things. So do I need to keep track of all this information? Yeah, I'm using a lot of memory. So let's see. Okay, so I have my starting values. I have a dictionary of all possible things. And then for every value in my array, if I find that there's a combination for this value, I increment that combination and add that to the dictionary of possible combinations. And then for every starting value, of which this is going to eventually be 1, I create a new possible sequence that is too long for that. I feel like maybe what if I ignored certain combinations? So for instance, if it was a combination that was 12, do I really need to add in 13, 15, 19, 23 into my dictionary? Probably not if no, I mean, I'm at a certain value. So there's so many possible combinations, I guess. There's so many possible combinations. So I'm inserting. You know what? Let me go ahead and create a set of all values that is in the array. And rather than blindly hoping that the sum is going to be found in there, I only do it for the ones that actually appear. So if the total, so before I do this, if the total is in values, then I actually take that into account. Similar to this one, if that total value plus last is in all values. So I'm restricting it to only like things that I know it appears in the sequence. I think this is still the same. Okay. This still might be okay. The memory usage is still kind of bogus, but runtime, that's pretty good. Okay, that was kind of rough at points, but yeah, daily done for my first